In Lesson 2, I will show you how to take data that has been collected and organize it into a visual display, a graph. The data before it is graphed or has been used in calculations is called raw data. It is always best to start with a graph of the raw data because the visual helps us decide how we should best analyze our data and report it honestly. This lesson will answer the following questions. What are stem and leaf plots? What are dot plots? What are bar graphs? What is meant by the term the distribution of the data? What are three key types of distributions? A formal definition of raw data is data that has not been manipulated or processed to find meaning. It is the first or primary measures on an observational unit. Let's look at an example of the homework grades of 25 students. The raw data was first recorded as you see here. We see scores from 0 to 100, but a graph would help us to see the data better. This is a stem and leaf plot of the data. The stems to the left of the vertical line are the tens value of each score. Each stem occurs only once. The leaves to the right of the vertical line are the ones values of each homework score, and there is a leaf for each score, 25. So I can now see the scores from lowest to highest. Reading top to bottom are 0, 0, 0, 75, 75, 80, 80, 90, 90, 90, 90, 90, 95, 95, 95, 100, 100, 100, 100, 100, 100, 100, 100, 100, and 100. Here is a dot plot of the same data. There is a horizontal line, axis, that is numbered from 0 to 100 in spaces of 5. We must have even spacing to ensure a fair look at the data. There is one dot placed vertically for each homework score. The dots should be of equal size and with equal spaces between. Our final graph is a bar graph. Note that there is a horizontal axis with score values of 0 to 100 spaced by 5s and a vertical axis which represents a count of the number of scores called the frequency with each value. The bar graph is easy to make from the dot plot or the stem and leaf plot. Time for you to practice. Make a stem and leaf plot, a dot plot, and a bar graph of the raw data on this slide. The answers are on the following slides, but don't look until you have tried each graph. You may use the table of contents on the left to go back and look at the examples given of each. Pause the video while you are working. Does your stem and leaf plot look like this one? You can pause the video while you are checking your work. The dot plot and the bar graph are on the next two slides. Here is a dot plot of the same data. Pause to check your answer. Here is the bar graph. How did you do? Which graph do you like best? They all display the data accurately. These graphs of homework grade data show different patterns of student grades. In the top graph, we see that most students did the homework and many received a 100. In the bottom graph, we see a very different pattern. Many students received a 0 on the assignment and only 4 received a 100. Each student has an individual grade, yet the data, the class's complete set of grades, has a pattern. This information will help the teacher make instructional decisions for the class. The pattern of the variability of a variable collected on observational units is called the distribution of the variable or the distribution of the data. Here are bar graphs of the test results for 3 classes, A, B, and C. The distributions of the grades have 3 very different patterns. In Class A, the scores are very evenly distributed around a score of 73. In Class B, most students scored high with a few scores lower, whereas in Class C, the opposite occurred with most scores low and a few high. The classes of grades on the previous slide illustrate three key types of distribution shapes. Class A is symmetric since right and left sides are approximately mirror images of each other. This example of a symmetric distribution is also mound-shaped or bell-shaped. Class B is skewed to the left since the low scores seem to pull the class away from the typical high scores. Class C is skewed to the right since the high scores seem to pull the class away from the typical lower scores. Can you now answer these 5 lesson questions? What are stem and leaf plots? What are dot plots? What are bar graphs? What is meant by the term the distribution of the data? What are 3 key types of distributions? Review Lesson 2 until you feel comfortable with them. This concludes Lesson 2. Lesson 3 is called Measures of Central Tendency. It explains ways to accurately describe the average value in a set of data.